So today we're going to continue our talks of random samples versus biased samples and how to tell the difference. So I think it's important that we start with just reminding ourselves what is a random sample, what is a biased sample. A random sample, we remember, is a sample, a small part of the population that you choose to answer a statistical question, and it's going to represent the population, and you know it's random, this sample, because everybody in the population has an equal chance of being picked. A random sample just means everyone has the same chance of being picked. It's all equal, it's all fair. So a biased sample is just the opposite. So some good examples of these, of a random sample, would be if I am drawing names for homework passes. The population is students that have all their work done. And what I do is I use a random wheel that has a random number generator that picks who gets to be picked. But everybody in that population of students that has their work done has a chance of being picked. So biased samples you see when it comes to making sports teams. And biased samples aren't a bad thing in that case, because you are taking the population of students at Mount Jefferson Junior High at a school, and you are picking the students that are most promising at a sport. Not everyone has the same chance of being picked, right? Like, if I were trying out for the basketball team, I would have a really low chance of being picked because I'm not good at basketball. Where students that are better at basketball, people who are better at basketball, like Mr. Arnold, if Mr. Arnold was better at basketball, he'd have a higher chance of being picked than I would. So when it comes to statistics, what we want is a random sample. So we're going to take a look at some sampling methods. We're going to talk about some sampling methods and decide, are they random or are those methods biased? Our first example is the producers of a television singing contest are conducting a survey on their website to see who viewers think should win the competition. Julie says that this method is going to create a random sample of people that watch the show. Well, do you agree? So let's think about the population, all people that watch this show. So would that be truly random? Well, in order to get to the survey, what do people have to have? Well, they have to have access to the website, so they have to have the internet. So no, this is not a random sample, it's biased, because there are probably a few people that watch the show that don't go to the website or have access to the internet. And because not everyone has the internet or goes online to their website, that means not all viewers, not the whole population, has an equal chance of expressing their opinions, of being picked for this survey. So let's take the example that the teachers at Mount Jefferson Junior High are asked to send 4 students from their homeroom to represent the whole grade. So there are a few methods that we're going to talk about. So think about some ways that I could pick 4 students from 7th grade to represent the whole class. So the first idea that we could use, we'll call it method 1. So in method 1, I could put all the names of all the girls into a box and choose 2 without looking, and then do the same for all the boys' names. So method 2 would be that I would send the 4 students closest to the door. And the final method that we could choose would be to put everybody's names in a box, mix the names, and then pull 4 out without looking. So here are our 3 methods. And again, the first one is putting all the girls' names in a box, then mixing it up, picking 2 randomly, doing the same with the boys. Method 2 would be to just send the 4 students closest to the door. And method 3 would be to put all of the 7th grade names in a box, mix it up, and then pick 4 without looking. So let's think about, how do these methods compare to one another? How are they random? How are they biased? So let's identify the random elements of these. So we're going to outline what is random about these in green. So we remember method 1 was putting all the names into a box, all the girls' names in a box, all the boys' names in a box, picking 2 from each. What's random there is the drawing names out of a hat. I don't have a bias. I don't pick which one. So that's a good, positive, random thing there, picking the names out of a box. It's also using the idea to break down our class into groups. So let's look for some randomness in method 2. That's where I would pick the 4 students sitting closest to the door. And that doesn't sound very random at all. I can't think of a way that would be random. So we'll get back to it when we talk about bias. And with method 3, it's where I'm putting all of the names of the students in a box, mixing them all up, and pulling out the 4 names without looking. And again, that's random names out of a box. So those are the random elements of our methods. And now let's add in some biases. So things that could be biased about each kind. So let's talk about method 2. That's kind of the elephant in the room here, where we really couldn't find a randomness to it. So this is biased. And how is this biased, you ask? This is biased because not everyone has an equal chance of getting picked to represent their class, right? I'm one who decides where you sit. I put you in groups based on where I think you're going to be really successful. Sometimes I'll sit you close enough to a friend for comfort, but not so close that you'll talk. But those 4 students that are sitting closest to the door, I was really careful when I made my seating chart, so it's not random. So method 2, it means that not everyone has a chance of being picked. So now let's revisit methods 1 and 3. So they both create a random sample, but is one better than the other? So let's think about it. We're going to get rid of method 2 because that we know just picking the 4 students close to the door is not a random sample. So let's just get rid of that. So now that we have it narrowed down to method 1 and 3, it comes down to some finer details here. So with method 1, we are putting all the girls' names into a box and picking 2, and method 2 is same with boys. And the only thing different between that and method 3 is breaking it into those 2 subgroups, girls and boys. So let's take a look at the other side. This creation of subgroups, it can be a very good thing, or it can be not a good thing, and it depends on how accurate your subgroups are. So it's really important when you create subgroups that there is a group that everybody fits into. So if we had a class where everybody identified as male or female, this would be a perfectly good random sampling method. However, if there were people that didn't identify as male and female and they didn't get put in either box for their names to be drawn out, that's not a random sample. It's important that when you're creating subgroups, you're making sure they're not biased. You're making sure that everybody fits into a subgroup, into one subgroup, so that everybody has an equal chance of being picked. My favorite method here is method number 3, because I don't have to worry about getting rid of biases in picking subgroups. I really like that it just turns into 20 names in a box, and everybody has a 1 in 20 chance of being picked to represent their class. So our last example is one about my gym. So I always like to start by identifying the population that I'm talking about. So the owner of my gym, CrossFit Black Bear, his population is members of CrossFit Black Bear. So the entire population is all of the members of CrossFit Black Bear. So what would be a good representative sample of this population? How could we take a good sample? So the sample would just be one that everyone has the same chance of getting picked. So next, how could we take a random sample where everyone gets the equal chance of being picked? There are a bunch of different ways that this can be done. He could give everybody a number and draw numbers out of a hat. He could use a random number generator. He could make sure to get equal numbers of people from different age groups, equal numbers of people of different genders. So what the owner could do, what Luca could do, he could break down the gym into male and female, and then break it down into age categories. People under 20, people between 20 and 40, and people in 40 and above, and take smaller samples of each subgroup. Because then he would get an idea of what each kind of gym member, men older than 40, women between 20 and 40, men under 20, what each group in the gym, which each subgroup would want. When we're making our samples, it's important to stay away from biased samples. We talked about how a good random sample would break things down into subcategories and then sample each subcategory. So it wouldn't be fair if Luca decided to break us into our gender and age categories and then only pick men and women between 18 and 25. That wouldn't give anybody older than 25, me included, a chance of being selected. It wouldn't give anybody under 18, and we do have some members that are under 18, they wouldn't have the chance to be selected for this survey. So that wouldn't be fair. So we're going to continue talking about how to use numbers from samples to make inferences about the whole population. So our example is that Luca has decided he wants to think about moving our 6 a.m. class to start at 6:30. So there are 250 members of CrossFit Black Bear, and I'm going to color code this. So when I'm talking about the whole population, I'll use red, and when I'm talking about the sample, I'm going to use blue. So he knows there are 250 members of CrossFit Black Bear, and he is going to sample 100 of those 250 people. So here you can see that we've got our sample of 100 out of the whole population of 200 gym members. So when Luca does his survey, he finds that 30 of those 100 people would be interested in moving class from 6 to 6:30. So what we can do, as we've seen before, is we can make this proportion. We set this equal. So our question is, how many people out of the whole population of CrossFit Black Bear gym members would want to change the time that class starts? So we set the 100 in our sample out of our total population to the 30 in our sample that said yes to however many in the population we think would say yes. Here we can use cross multiplication. So again, we're going to circle, and it would be 100 times x, so 100x. You're going to set that equal to this side, 250 times 30. So then what we do is we can divide both sides by 100 to find our answer, and we divide both sides by 100, we get x equals 75. So 75 people out of the whole gym would want to move class from 6 to 6:30. So let's do another example of how we can use samples to make some assumptions about a population. So our example is that I'm taking a survey of students in Penobscot County in 7th grade about the hours they sleep every night. So let's say that population is 5,000 students. And I'm going to take a sample of 150 students. So we're going to set up our first ratio where I took 150 out of the original 5,000 students. So I asked those 150 students how much they sleep each night. And I found that 72 students surveyed said they sleep for 9 hours every night. So I'm setting this up as a proportion. So the total number of people in my population, the total number of people in my sample, the number of people in my sample that sleep 9 hours, and what we don't know is the total number in the population that probably sleep 9 hours. So we're going to set that equal to x, and again, we are going to use cross multiplication here. So I'm going to make this part go a little bit faster. Just because we've done it a few times, you're going to have a pretty good idea of how to do this.
150x equals 5,000 times 72. 5,000 times 72. That would be 360,000. Divide each side by 150. 360,000 divided by 150. 60,400.
After doing a little bit of cross multiplication and some algebra, we can figure out that out of the population, there are probably 2,400 7th graders in Penobscot County that get 9 hours of sleep every night. So the two important things we talked about today were how to identify and create a random sample and make sure it's not biased. And the second thing we talked about is we continued talking about how to use the results we get from a survey to make some assumptions about an entire population. And it's important to remember that our assumptions aren't exact. If you take a sample of 100 people out of a population of 1,000 and 30 of them say their favorite color is red, that doesn't mean exactly 300 people in the total population would say their favorite color is red. But that is going to be a really good estimate if we have good random sampling methods. So you can continue to use these ideas as we talk more about statistics and probability throughout this unit. All right, thanks you guys. Have a good day, be kind, and work hard.